speaker is our headliner. He's our keynote address. Brian Richter came from Virginia, although he claims brother to Mexico. He has been a global leader in water science and conservation for more than 30 years. He is president of Sustainable Waters, a global organization focused on water scarcity challenges. He previously served as director of the Global Water Program at the Nature Conservancy. Brian has consulted on more than 170 water projects in 40 countries. I'm not sure I can name 40 countries. He has served as a water advisor to some of the world's largest corporations, investment banks, and United Nations, and has testified before U.S. Congress on multiple occasions. His scientific papers have been cited more than 36,000 times. And his latest book, Chasing Water, a guide for moving from scarcity to sustainability, has been published in 5 different languages. Please welcome our keynote speaker, Brian Richter.
Thanks very much, Lewis. So how's the sound check at the back? You everything all right? Okay, great. So I'd like to start by following what Lewis and what Paul said, extending a personal thank you to each and every one of you in the audience. Okay. Your presence here to be part of this conversation about water, if you're like me, it springs from a really deep concern and care and love for the water, for the land that shapes the water, and for the communities that we share that water with us. So thank you all for being here. Personally, I find myself at a really, really interesting time in my life. I finally retired on this past New Year's Eve. And I mention that because, as Lewis said, I spent the last 4 decades traveling all around the world, working in more than 40 different countries. But for the first time, I really have the time to slow down and to reflect and to contemplate and to think about the things that I've learned along the way. And so I want to thank you for this opportunity to share some of those reflections and perhaps a couple of things that I've learned. I'm going to start by saying that I think this word is the most important word in the water conversation taking place in local places, local basins all around the world. This word really gained a lot of popularity, a lot of momentum back in the 1980s. It was a time that there was growing concern around the world about the impacts of the rising tide of humanity on the natural resource base of the planet. And so the United Nations at that time convened a commission led by a guy named Arnold Brundtland, and so the Brundtland Commission, to take a look at this, to think about this, to think about humanity's future, to think about the consequences for the planet, to think about the future. Are we doing enough to make sure that the future generations are going to be okay and enjoy the same quality of life that we have? And so you see the definition there, meeting the needs of the present. This is out of their report, Our Common Future. Meeting the needs of the present without compromising the ability of future generations to meet their own needs. To translate that a little bit practically and to apply it into water management challenges, this really means avoiding the depletion of natural resources, and in our case specifically of the water resources. But the way I really like to think about this is in more personal terms, more human terms, because this is why you're all here, or this is why you all got into this profession, was because you don't want to lose something that you care deeply about. You want that to persist. You want that to be sustained in the future, and you want our kids and their kids to be able to enjoy this new opportunities. I will say that during my 4 decades of work, that one of the aspects of the global hydrologic cycle that fascinated me the most, and one that's highly pertinent, of course, to all of you out there in West Texas, is this magic that happens when underground water, when groundwater reveals itself at the surface of the land. And as you can see from this simple diagram, we know how this happens. that rainfall and snow falling on the landscape percolates down, enjoys typically a big saturated body of water. And in places where a stream or a creek runs through that landscape, it intercepts that underground saturated water, intercepts the water table, and that water table, that underground water, flows into that spring or that creek, into that stream or creek, I should say. And in fact, this is the reason why we have perennial rivers. And Texas is very well endowed in many respects with its water resources. This is a map. It's not sure you can see there. But it's a map of all the perennial rivers in Texas, including a lot of them in the western part of the state. And so the reason that we have continuously flowing rivers is because that magical phenomenon, that process that happens where underground water is contributing to the flow of a river, even when it's not raining, even when the snow is not melting and gushing down the rivers and streams. So it's that underground water that keeps these rivers and streams alive. The other process is so important to all of you, and that again, I think is part of the magic of this underground water repeating itself, is something that Paul just talked about, this phenomenon of how springs happen, where water that is infiltrated into the ground surface, and in many cases, many thousands of years ago, ends up getting trapped under a berm of rock, soil. It's what we call confined or trapped beneath these layers of rock. But that water, much of that water in certain places on the planet finds these cracks and fissures in that overlying berm and escapes the underground system. It's under pressure and it rises up in these fissures and cracks in the rock, in the overlying berm, and emerges as springs. And again, Texas is very well endowed. This is a map compiled by the Spring Sustainability Institute based out of Flagstaff, Arizona. And this map is accounting for more than 4,400 individual springs in the state of Texas. So pretty phenomenal water heritage that you all have here that Paul spoke so eloquently about. And so these are the phenomena that give rise to these magical places. The places like Dolan Falls on the Devil's River, or places where water emerges out of the rock, out of the side of a wall in places like Comal Springs. But also in places where the water has just saturated the soil and maybe is ponded on the surface, forming these wet meadows. And these are places that are all of these places are remarkable gatherings of biological life. You can see the statistic there at the bottom of the slide. I think this is pretty phenomenal to contemplate, that nearly half of all freshwater ecosystems on our planet depend either wholly or in part upon groundwater, on this magical intersection between the land and underground water. I personally know of a couple of these places here in Texas. My extended family are all Texans, mostly around between Austin and Dallas. But my grandfather owned a farm in a little tiny town by the name of Theon, north of Austin. And he had a little spring creek on his property called Austin Creek. And it was a wondrous place to visit as a kid. You know, when I was 7 or 8 years old, we would take Grandpa owned a general store there in the town of Theon, and we would take these empty Hormel hand cans and drop them down at the bottom of the creek, because we knew that the catfish would come and move into those little houses. And a couple of days later, we could come back and pull the Hormel cans out of the creek and have a catfish and bring back home to Grandpa to cook up for us. But really, what the issue that we're here for is our concern over the fact that our utilization of this natural heritage of water can have impacts on these biological phenomena, on these freshwater ecosystems, on these springs, and on these perennial rivers. And so when we drill wells and begin to tap those water sources, we can lower the water surface in these shallow underground aquifers, we can reduce the pressure in those deeper confined aquifers, and that has the consequence of decreasing the amount of water flowing in the creek or the river, flowing out of those springs as well. And so we do need to be very, very careful about that. These are very, very sensitive systems. This phenomenon of groundwater interacting with the landscape is very tenuous. It's very sensitive and very subject to what might seem to be very, very small perturbations, very small levels of human utilization. So, Lewis mentioned that a few years ago I wrote this little book called Chasing Water. And I wanted to read you one of the passages from the book. I said, we possess the means to wring every last drop from the planet's rivers and lakes, or to suck its aquifers dry. But is that really what we want to do? Or do we instead want to leave some water alone, enough to fuel the biological engines of our planet, or to serve as a hedge against dry times and an uncertain future, or simply to irrigate our souls with the intrinsic beauty of flowing water? Can a river still be a river when the water is all gone? It was the question I posed. And so I want to tell you a story about one of my favorite places. I live upstream from all of you now, in northern New Mexico. My home river is the Rio Chama. And the Rio Chama is a really important tributary into the main Rio Grande. And so I spend a lot of time floating that water in canoes and rafts, and kayaks, and I've gotten to know these stretches of river and come to love these places a great deal. But we have a lot of concern about the Rio Grande up in New Mexico, and I would say throughout the entire system this is taking place now, unfortunately, in that there are more places that are going dry at different times of the year, during the drier times of the year. And many of these places are staying dry for longer periods of time. So it's a very concerning trend, and one that I think we really need to address in a very concerted way and with due haste, I would argue that. So as we've looked into what's going on with the Rio Grande, there are three things really that we've come to understand about what's going on and why the river is beginning to suffer the way that it is. First, we're getting less water from nature. There is less replenishment coming each year from the melting snows up in the headwaters of the Rio Grande, in the San Juan Mountains and San Marino Cristo Mountains in Colorado. And it's something on the order of this century, during this century, since 2000, have the flows, the contributions of that natural replenishment has been about 17% lower than it was in the past century. So that's been very, very challenging and poses some real difficulties for those of us that depend upon those water flows in the Rio Grande system. And in fact, we haven't been able to adjust to that changed water availability at the pace and at the magnitude that we need to. So we are beginning to see that we have been overusing the available water supply that's coming down the river each year. And so as a result of that, we've been tapping into the water stored in our reservoirs to the point where now we have nearly depleted all of the water storage in the New Mexico reservoirs in the Rio Grande system. You see there a very emblematic Elephant Peak Reservoir at the end of last year was open at only 3 new shed capacity. At the end of last year, the reservoirs in New Mexico were down to 13% of their capacity. And the outlook for this year, tragically, is that we might lose all of the rest of the storage in those reservoirs because we're looking at a very, very wickedly bad dry year. So there's the statistic. These reservoirs have lost 71% of their storage. We may lose another 13%, the last 13% in this year. This has also been a great concern to the farmers that are dependent on this water. About 90% of the water being consumed in the New Mexico portion of the Rio Grande system goes to irrigated farming. And that lack of reliable water supply has been the undercurrent causing a lot of these farms to go out of production. Some of them are going out of production because the farmers are getting old. They're needing to retire. Their kids aren't going to take them and farm. And some of them are having trouble accessing labor or the cost of labor. But running underneath all of these issues is the fact that they're looking at a future with perhaps a lot less water supply. And so a third of the farmland in New Mexico is about out of production globally. Because of the lack of adequate surface water, the farmers understandably have been pumping groundwater at an increasing rate. And really have been going at it. So you see here the trend of what's happening with the underground volume of water in the New Mexico portion of the Rio Grande. For those of you that know numbers like acre feet, the fact that we're losing about 500,000 acre feet per year of groundwater is a great concern. I see the map there on the right. The coloration there indicates the different degrees of depletion of the aquifers that are taking place. And this is an issue that we really need to address, not just in New Mexico, but in all parts of the Rio Grande Basin. Colorado is struggling mightily with it. The Rio Conchos in Mexico is struggling with it, and also here in Texas. To connect these things of that magical phenomena, the intersection of the landscape with this underground water, with this groundwater, it's been estimated that about a third of all the groundwater being pumped in the state throughout the Rio Grande Bravo Basin is actually reducing the flow in springs and in rivers. So 1/3 is capturing that spring flow and that river flow. So there we see, the magnitude, degree of connection to these things. In New Mexico, we're really up against the wall. Only 15% of the water being consumed in the state now is naturally replenished by snowmelt, rainfall, and aquifer recharge. The other 85% is being supported by depleting those reservoirs, depleting the aquifers, and drying up the rivers to the pieces of. This is highly sustainable. And again, I will say it presents a tremendous challenge. So it begs the question, which is why we're all here, I think, is to really understand what can we do to protect the rivers and springs that we need and love. The springs and rivers that Paul spoke so eloquently about a moment ago. I could spend days talking with you about the myriad strategies that are available that we try and test all around the planet. Many of them being with considerable success. But those are really the details, and those strategies need to be custom tailored to each and every individual place. And because they're not appropriate, there are no silver bullets here. But there are a lot of ways to approach this problem. And so I would like to share with you just a couple of thoughts that I highlighted in the Chasing Water book. What I call the 7 principles for sustainable water management. And in particular, I want to highlight the first 2 because I think by far and away these are the 2 most important. The first is really to foster and engage in what I called in the book local water democracies. These are the conversations that take place, yes, in auditoriums like this, but also in localized fora that are focused on the local river system, the local aquifer system, and that sort of thing. These are the places that you need to show up and speak up to make sure that the things that you care about, the things that you want to have sustained, are going to be perpetuated into the future. Okay? And so you're very fortunate. I highlighted the work in Texas to create the framework, the planning frameworks, the local water democracy dialogues that are being fostered, facilitated in the state of Texas. And these 2 things that you've heard talk about, for those of you that were here yesterday, the groundwater conservation districts, which are focused on the aquifers and their interaction with what's going on with the surface features that all of us care so much about. And those conversations about aquifers and springs and base flows, they feed up into the larger regional water planning groups that all together collectively form the state water plan that's refreshed and renewed every 5 years. These are the opportunities to each and every one of us and to each and every water user in the state of Texas. This is your opportunity, and you need to take advantage of that opportunity if you're concerned about the things that you care about being trees. I pulled just a couple of examples of some of the work of these groundwater conservation districts, and we heard yesterday that it's their job to set these goals that are called desired future conditions. And these two I picked out just because they really clearly express the intent of those districts to protect spring flows. They're very specific about the rate at which they want these springs to continue to flow. And so once you've set those goals, then you reverse engineer everything. It determines how we use the water, how much water we can use, so that we don't impair that goal, the realization of those kinds of goals. I'm going to leave you with this image that's been seared in my mind's eye for the last decade. This is a picture of kids who grew up in the delta of the Colorado River. These kids, for all of their life, had never seen water flowing in the Colorado River. They just knew it as a big, gigantic sandbox. Not a whole lot going on there. But back in 2014, a coalition of conservation groups got together and they worked with farmers in Mexico and compensated the farmers for using less water than they had been using. And they aggregated that saved water in a reservoir right on the international border between Mexico and the United States. And they saved it up, they cooled it up, and then for 3 glorious weeks in June of 2014, they let it rip. Because the scientists wanted to demonstrate and to gain a better understanding of what can happen if they could restore some semblance of the spring floods that used to come rushing down through the Colorado River system all the way from the Rocky Mountains all the way out into the Gulf of California each year. And so for 3 weeks, these kids, and their parents, by the way, there were pickup trucks lining the river, radios blaring. It was a 3-week-long party. But nothing tells you about the joy like you see on these kids' faces. So I'll leave you with this thought. If we can begin to restore the water, we will restore the human spirit. Thank you very much.